All right, we're going to get to our last lesson of this unit on polygons and quadrilaterals. And the last thing we need to talk about is shapes on a coordinate plane. And I think we've brought this up before, but we're going to be on page 107. And we're just going to kind of finalize some thoughts. And I'm going to do 3 examples on these situations. So I'll bring up my document camera here. Again, we're on page 107. Okay, and we're going to talk about distance, midpoint, and slope. Okay, and we can apply these 3 things to some of our quadrilaterals. Okay, and for distance, distance is the length between 2 points, or the length or measure between 2 points. And it has a formula, and the formula actually comes from the Pythagorean theorem. So if you forget the formula, you can just use the Pythagorean theorem, and I'll kind of show you in a picture what that might look like. But the actual formula is d for distance equals the square root of x minus x1 squared plus y minus y1 squared. Okay, and x and y and x1 and y1, those are just 2 different ordered pairs. Okay, so don't get mixed up in the x1, y1, xy situation. Just know that those points correlate with one another or correspond to one another, and they also are 2 different ordered pairs. The next thing we have is midpoint. Now, midpoint we won't use as much, but we can use it. And midpoint is the point that bisects a segment. Okay, remember bisects means to split in half. So this is the point that splits a segment in half or divides it into 2. And we can find that point by taking x plus x1 over 2, comma, y plus y1 over 2. And this is an ordered pair because it is a point. It is the midpoint. Okay, it's kind of the, most call it the halfway point. Okay, and then the last thing we have, which we will use quite a bit along with distance, is slope. And slope is the measure of steepness between 2 points. Noted as rise over run, which is probably how you learned it in algebra class, rise over run. And slope is usually noted or labeled with the letter M, and it is the change, which that little triangle stands for change of y, which is your rise. Remember, y goes up and down on my axis, over your change in x, which is your run. Running goes left and right on the graph. So change of y over change of x, which formula might be y minus y1 over x minus x1. Again, in that one, just like the previous formulas, x and x1, y and y1, those are 2 different ordered pairs. Okay. So some things to note here, or some things to remember as to why we use these. So let's note I've got 4 of them. Number 1, x, y, and x1, y1 are different points. Okay, so those are different points on each of the formulas. Number 2, segments that have the same distance are congruent. Okay, so if you use the distance formula and you note that 2 segments have the same distance, those segments are congruent. Number 3, segments with the same slope are parallel. Okay, again, if you use the slope formula and 2 segments have the exact same value for that, then they are parallel to one another, meaning they have the same steepness, because that's what slope measures. And the last one, number 4, segments with a negative reciprocal slope are perpendicular. And what negative reciprocal looks like is maybe you have one slope is 2/3 versus the negative reciprocal of that would be the opposite sign, so negative, and then you flip it over, 3/2. So those 2 are negative reciprocals. Okay, I've got 3 examples to look at here with these. And we may not have enough room down here, so we can actually go to page 106 if we need to. Okay, I'm gonna write these in pen. So the first one, what shape is created by points A is at 2, 1, B is at 2, 4, C is at 11, 4, and D is at 9, 1. Use slope and distance to solve. Okay, and I did run out of room, so we'll go over here, but we want to use slope and distance because not always will I be able to graph these on graph paper. Okay, so I'm gonna kind of do it on plain copy paper so that you can see. The second one says if A, B, C, D is a rhombus, find the missing points. Okay, and they give you this graph here, which is not drawn to scale here. So I'm just going to put points in openings. Okay, they say this is XY. This is some number, comma 12. And this number right here is 13, 0. And then the last one we want to do is use distance and slope to determine the shape. So then it gives you this shape here. So 3, 4, 7, 4, 7, 1, and 3, 1. Okay, and it put it as a rectangle. It may or may not be a rectangle. Okay, so we want to use slope and distance on these to help solve them. So I'm actually going to do that on a separate sheet of paper. Just a plain sheet of printer paper to do this. So if you need to finish writing those down, go ahead and pause. If not, you can keep watching. Okay, so the first one, what shape is created by points A, B, and C? Okay, so I'm just going to jot those points down. And it doesn't matter what shape you draw. We at least know it's a quadrilateral because it'll have 4 sides. So we'll put A here, and you want to just kind of get the points in the right location. So A here would be at 2, 1. B would be at 2, 4. Okay, so I know that is to the right of A. C is at 11, 4, and D is at 9, 1. Okay, so those are kind of in order just a little bit. So what I need to do is I need to find the distance between all of these points. Okay, I need to see if these distances here are the same or if these are the same, all of that kind of stuff. And then I also need to look at slope. Okay, so I'm going to kind of organize this and I'll put AD and we'll find that distance. I'll put AB, we'll find that distance. We'll put BC and we'll find that distance, and we'll put DC and find that distance. Now remember, this is the distance formula here, okay? So you just take an X and a Y, and you take another X and a Y, and you just plug in those numbers. So the distance between A and D, so we'll take the square root, and I'm just going to use these as my X's and Y's, and these will be my X1, Y1. So I'll take the X's and subtract. So 2 minus 9 squared plus, now take the Y's. 1 minus 1 squared. Okay, 2 minus 9 is 7, or negative 7. Negative 7 squared is 49. So I got the square root of 49 plus 1 minus 1 is 0. 0 squared is 0. So you get 0. Okay, so 49 plus 0 is 49. And the square root of 49 is 7. So this distance here, this is a different color here. This distance here is 7. Okay, so now let's go see if this distance is 7. Okay, because remember, parallelograms, the opposite sides are the same length. So if we see that it's a parallelogram, if we see that these are the same, then we can start going down the parallelogram. If these aren't the same, then we can start looking at trapezoid or those sort of things. Okay, so let's go down to BC. Okay, BC. So I got the square root of x, so 2 minus 11 squared plus 4 minus 4 squared. Okay, well, I know 4 minus 4 is 0, and 0 squared is 0. And if I add 0, nothing changes. So all that goes away. So 2 minus 11 is negative 9. Negative 9 squared is 81. And then you have the square root of 81, which is 9. So this distance here is 9. So I know automatically that it is not a parallelogram because these distances aren't the same. So if we kind of go back here, you could follow along this chart if you wanted. We could have looked for the diagonals and then parallel sides. We could also use this here, and we know like both pairs of opposite sides are not congruent. So that marks out all 4 of those. So it cannot be a rectangle, rhombus, square, or parallelogram. All right. Sorry, we were switching classes here. So let me get back here. Okay. So we were finding, we had found the distances and determined that it wasn't a parallelogram. So our next course would be to look and see if it could be a kite or a trapezoid. Now, if it were a trapezoid, 2 of the sides would be parallel. Okay, so we can go ahead and check slope. Okay, so this was distances. Okay, and then this will be slope. So we could say AD slope, DC slope, BC slope, and AC AB slope. Okay, so again, from here, slope is you subtract the y's over subtract the x's. So from A to D, if we subtract the y's, we get 1 minus 1 over subtract the x's would be 9 minus 2. Okay, 1 minus 1 is 0, and 9 over 2, or 9 minus 2 is 7. 0 divided by 7 is 0. And when you have a slope of 0, that means you actually have a horizontal line. So I kind of drew this thing different. These 2 points should have been switched, but it's still fine. Okay, so that has a slope of 0. And if we go to this line over here, let's see if it also has a slope of 0. If it has a slope of 0, these 2 are parallel. So let's go to BC. Okay, so we have your y's. So 4 minus 4 over subtract your x's, 11 minus 2. 4 minus 4 is 0. 11 minus 2 is 9. So 0 divided by 9 is 0. So these 2 points are parallel. So, or these 2 segments are parallel. Okay. And we can do some thinking. We actually don't need to find the slopes of these other 2 because we know that they can't be parallel. And these 2 segments cannot be parallel because these 2 are not the same length. Okay. Again, it's not a parallelogram. So all pairs can't be parallel. Okay, so we have 1 pair of parallel lines. And if we look here, we have that exactly 1 pair of opposite sides parallel would be a trapezoid or isosceles trapezoid. Okay, and the only difference between an isosceles trapezoid and a trapezoid is the isosceles trapezoid has your non-parallel sides the same length. Okay, which means these are my parallel sides. So my non-parallel sides would be the same length. So we need to go ahead and find the length of AB and the length of DC. So let's start here with AB. Okay, so we have the square root of subtract your x's. So that's 2 minus 2 squared plus subtract your y's. 1 minus 4 squared. 2 minus 2 is 0. 0 squared is 0. And if you add 0, all that goes away. It doesn't matter. 1 minus 4 is 3. 3 or negative 3. Negative 3 squared is 9. So you have the square root of 9, which is 3. Okay. So this length here is 3. Okay. And then DC. So DC, we take the square root of subtract your x's. So 9 minus 11 squared plus subtract your y's. 1 minus 4 squared. So 9 minus 11 is negative 2. Negative 2 squared is 4. Plus 1 minus 4 is negative 3. Negative 3 squared is 9. 9 plus 4 is the square root of 13. And 13 is a prime number, so we can't break that down. So this distance was the square root of 13. So you can see that these two distances are the same. In fact, all your distances are the same. So this is just a trapezoid. Okay, just a trapezoid. I have one set of parallel sides and no congruent sides. So it is a trapezoid. Okay, a little bit different trapezoid. In fact, as I was setting it up, this is the trapezoid that we have. Okay, I've got parallel sides here and all sides are different length. Okay, all right, moving on to the second one here. If ABCD is a rhombus. Now, because it is a rhombus, all 4 sides are the same length. Okay, and it says find the missing points. So I have a blank here that I'm probably going to need to find, and XY, I need to find that. Okay, so I'm going to draw it over here on this page. I'm going to draw it how it is. So I given this point, and this kind of goes up like that, and like that, and like that. I know that this point here is 13, 0, which means I go over 13. And we said that all 4 sides are the same. So if this is 13, okay, if this was 13, this is 13, this is 13, and this is 13. So all of those are 13. And it also gave us that this point up here was blank, 12. Okay, which means I went over some more. It's going to be more than 13. I went over so much more, and I went up 12. So this is 12. Now, right here, we have a right triangle. And I need to know how much this portion is right here. Okay, so this is X. I need to know that little portion. Well, to find a side of a right triangle, we just need to use the Pythagorean theorem. My hypotenuse is 13. So I have X squared plus 12 squared equals 13 squared. So 12 squared is 144. 13 squared is 169. And you've got your X squared there. Subtract 144. X squared equals 25. Take the square root and you get X to be 5. So this distance right here is actually 5. So you went over 13 and then 5 more, which 13 plus 5 would give you 18. So this point here is 18, 12. Now we also need to find this point here, which is XY, they say. But it will be the same height as this point over here. So it will be 12 for the Y. Okay. So again, I can make a right triangle here. So I go here. We know this is 13. We know the height is 12. And I just need to find this X value right here, which I did over here with the 5, because I had the hypotenuse was 13, the height was 12, and this piece would be 5. So this point is actually 5, 12, and this one was 18, 12. So this one is 18, 12, and this is 5, 12. The most important part here is that it's a rhombus. Because it's a rhombus, I can treat all the sides the same, which was at 13 that they gave me. Okay, the last one, use distance and slope to determine the shape. Okay, so again, I'll kind of flip this around. I'll put the shape here. Try to orient it correctly this time. So I got 3, 1, 3, 4. This is 7, 4, and this is 7, 1. Okay. Now you can kind of do the distance formula in your head just a little bit. Okay. Both of these go to the right 3. Okay. So they're actually right on top of each other. Okay. And if these are on top of each other, the distance between the point 1 and the point 4 would be 3. If this is 3, 1, you go up 3 spots, that's 4. If we come over here, they're both at 7, 7 and 7. So they're right all the way to 7. So they're right above each other. So you got 1 to 4 again, which is the same 1 to 4 here. So this is also 3. So these two sides are congruent. Okay, which it could be a trapezoid, it could be a rectangle, could be a square still. So we got a lot of options. So let's look at the distances between here. Now notice they're both at 4, but the 3 and 7 is different. So if they're both at 4, they're horizontal to each other. So going from 3 to 7 would be a 4. Now down here, they're both at a height of 1, but you got a 3 and a 7 again, which is also 4. Okay, so this is the same as this, same as this, same as this. Okay, but that's not enough, okay, to prove what it is, because it still could be, it could be a parallelogram or it could be a rectangle. I don't know. Okay, I need to find these angles here. So in order to look at the angles, we're going to look at the slopes. Okay, and I have, let's just label these A, B, C, and D, kind of help us organize our work a little bit. So if I want the slope of AB, that is subtract your y's, so 4 minus 1 over subtract your x's, 3 minus 3. Okay, so you got 4 minus 1 is 3 over 0. So you have this would be an undefined slope, which means you have a straight vertical line. Okay, so this one's vertical. Let's see what this one is. Okay, so this is BC and then CD. Okay, so subtract your y's. So 4 minus 1 over 7 minus 7. 4 minus 1 is 3 over 7 minus 7 is 0, which you can see 3 over 0, 3 over 0. So both of these are vertical segments. Okay, they are parallel. Now let's see if these are parallel. So BC, so subtract your y's. So 4 minus 4 over 7 minus 3. Okay, so here we have 4 minus 4 is 0. and 7 minus 3 is 4. So then you have a 0 divided by 4 is 0. Okay, so a 0 slope means horizontal. And the last one we need to do is AD. So AD would be subtract your y's. So 1 minus 1 over 7 minus 3. 1 minus 1 is 0. 7 minus 3 is 4. And 0 divided by 4 is 0. So this is also horizontal. So these two lines are parallel to each other because they both have a slope of 0. Now, the thing is, this is a horizontal line and this is a vertical. If you have horizontal lines that meet up with a vertical line, what you create here, here's my vertical line, here's my horizontal line, you created a 90-degree angle right there. Okay, those are considered negative reciprocal slopes here. So you have a 90-degree, a 90-degree, 90-degree, 90-degree. Okay, so you have two pairs of parallel sides and 4 90-degree angles, which would make it, which makes this a rectangle. Okay, makes that thing a rectangle. Now, if we go back to this trapezoid here, okay, I again had a horizontal and vertical segment, okay? And so this would have a slope of 0, and this would have an undefined slope, okay? Now, that's not the only way to get your 90-degree angle. Let's say again, I showed an example earlier, but let's say we have a slope of -1/2. Okay, that slope of -1/2. If the other slope was a +2, these are considered negative reciprocals because this would be 2/1. So I changed the sign and flipped it over. So whatever these were, they have a 90-degree angle. So if I graph this, let's say here's the point. Let's graph 2. So that's up to right 1, up to right 1. So there's that slope. Okay, and let's go from here. Let's go down 1, right 2, down 1, right 2, and there's that slope. Okay, so these were negative reciprocal slopes, and hopefully you can kind of tell right there I have a 90-degree angle. I'll just take a piece of paper there, and it fits right there, that 90 degrees. So this is 90 degree. So anytime you have a negative reciprocal slope, -5/7 versus 7/5. Those are negative reciprocal slopes, so they create a 90-degree angle. Okay, so that's the last thing that we had for this unit on polygons and quadrilaterals. So we'll be reviewing and testing shortly. If you have any questions, feel free to reach out. I'll see you in the next lesson.